Yes, Vinayak, I think we are getting streamed in YouTube. Just check it out if you are able to uh, find the link on YouTube from your side. We will just drop a message to Srinidhi also to join for the session.
Yeah, we are going live on the YouTube.
Great. Could you please just share the screen, share the link to all the students also?
Yeah, I'll just share it. Just mail.
Yeah. Hello, Srinidhi. We are live on YouTube.
Hello,
So,
sir.
hello. Hey. All the students will be joining through our YouTube channel as well. So I think it's still 3:50. We still have 10 minutes to go.
Okay, sir.
Let the student join, and then I will hand over the session to you.
Sure, sir.
Yeah, thank you. Vinayak, is the email sent? Just also coordinate with Naveen in case that has been also sent to other students.
Yeah, email has been sent, and I've shared the link with Mr. Naveen.
Naveen, I just checked with the college team size. So if they have joined the meeting.
Yeah, it's sent.
ನಾನು ಫಂಕ್ಷನ್ ಹೋಗಿದ್ದೆ ಒಂದು
Naveen, just in case, inform the faculty as well. If somebody is going to join in our Zoom meeting uh, to describe or discuss about the session.
Suraj, I will go to inform to Dr. Praveen, definitely. Just wait for a second.
Sure.
Suraj, sir is online. You can start the session.
All right. Yes, Naveen, we can definitely get started. Just checking if there are participants on YouTube channel as well. 1 second. Okay. Right. I mean, I think we have communicated the information to all the students right now. Yeah, I think we have about 17 participants in the YouTube live. So yeah, I think we can expect some more. Should we wait or shall we get started?
Sir, can you please wait for 2-3 minutes more?
Definitely, Praveen. So we'll do.
Okay.
Yeah.
We will directly.
Yeah, Praveen sir, whenever you would like to start us, we are ready.
Praveen sir, shall we start?
Yes, sir.
It's getting
Yes,
late.
yes, sir. Yes, sir. Yes, sir. We can start, sir. Students will be joining in a few seconds.
Okay, sir.
Surely,
No
Session.
problem.
They
Okay,
can
okay.
definitely attend the session, because in YouTube they can actually go back few minutes also and attend the topic.
Yes, yes, sir. Yes, sir. Yes, sir. Yes, sir.
Absolutely. Great. So, by the
Okay,
way,
sir.
yeah, thanks. By the way, good evening to all of you who are present here in the meeting and also who are present in the YouTube live. Thanks a lot for giving your time and interest to take up the session today, which can be defined as a webinar on battery management system practical demonstration. So, in association with Guru Nanak Dev Engineering College, Bidar. And thanks a lot, Mr. Praveen sir, for coordinating all the activities, and Mr. Naveen coordinating for all the activities to ensure that the session is going to happen for all the coordination with the students as well. So before we get started with the session, so I would like to have any interaction that Praveen sir would like to make for the session today.
Thank you very much, sir. Sir, we feel very happy to organize this webinar on BMS practical demonstration by Decibels. And Naveen sir and me are very good friends from past many days. So we planned 2-3 times, but it cannot be done. But now we planned, and I'm very happy to do this webinar. So we'll start this webinar, sir. Students are waiting.
We'll get started with the session right away.
Yes, sir. Yes, sir. Yes, sir. I welcome each one of you to this webinar.
Surely. Thank you. Thank you very much, sir.
Okay.
Anyway,
Right.
hey everyone. We will be having Mr. Srinidhi to deliver the session. So before that, let me give you a good note of introduction on what we're going to cover today. So as we defined in the whole topic, this is a session that will be delivered live through a YouTube lecture. So thanks everybody for attending it again. So overall today, BMS, if you see, battery management system is a very critical, important component. So if you see a lot of scenarios where the batteries are catching fire, or you have a defined range, but the vehicle will not give you a range. A lot of these scenarios happens because the algorithms in the battery management systems may not be very, very accurate or very good to take care of it. So the BMS will become a very important component of an electric vehicle today, or not only electric vehicle, any battery pack managing system today. So that's such a way that it will ensure that there is a safety for the vehicle, or safety for the batteries as well, or battery pack or a module also in any cases. So Decibels has been engaged in conducting such kind of a training program. This is one of the example like webinar where you will be delivering about a 45 minutes of a lecture, so that you will be understanding some basics of it. But if you also want to learn extensively, we will also offer a lot of training programs that can be very well helpful for you to build your career as well. We have 9 months program on electric vehicle technology, also on the battery management system itself. If you are interested to definitely build your career in the battery management system or in the electric vehicles. But also we have courses which we call as a micro specialization program, if you want to learn about only on BMS to a short note, and also on the powertrain. So such a way that you will be able to enrich your skills and build your career in the EV sector. So, but yeah, let's get started with this session so that you will be able to understand what is BMS and how does the BMS work, and how does the mechanical and electrical connections are there in the battery management system. To make this session happen, I'll invite Mr. Srinidhi to take guide this session. Srinidhi, I'm giving you an option that you would be able to share your screen. I think he has some internet connectivity issues. Vinayak, could you please just check? Srinidhi has a connectivity. Yeah, he has joined the session back.
Hello.
Yes, Srinidhi, can you hear us?
Yeah. Yes, sir.
So we just briefed your introduction. I think you're good to go ahead to start the session, Srinidhi.
Okay. Shall I share my screen now?
Yes, you can go ahead, please. I'll stop sharing. Yeah, you can start with the session, Srinidhi.
Okay. Thank you, sir. Good evening, all. I'm Srinidhi, R&D engineer at Decibels Lab Private Limited. So today's session is on battery management system functionality. So we'll be looking up at how actually the BMS works, what are the main functionalities of it. We'll also look on the demonstration a live demonstration on the vehicle level, how this functionality will take place. So things which we would cover today are the hardware overview, what all how the complete BMS hardware looks as an overview. If you look at what are the components, main components you can see inside them. I wouldn't say in depth of individual components, but as an just a overview of the complete BMS we would be discussing. Then another major point is how do we integrate it with the battery pack? How a BMS is integrated with any lithium-ion battery pack. Then the software interface. How do you configure each parameters of BMS? We'll be looking at that. Then battery pack and all complete information on the software side, which will be fed to the hardware part. We'll also look at on what basis, on what databases do we set this configuration. Then how does a balancing happens in a BMS? What are the types of BMS balancing takes place in a BMS? We look at some examples. What happens when charging? How does BMS balances it while discharging? How balancing takes place? Then what are the ways of BMS data acquisition? How do we collect the data, log the data, and how can it be used? So before we go ahead with all the working of the BMS, I would like to discuss on why do we actually need the BMS? Why do we require a battery management system? As you all know, lithium-ion battery packs are not so easy to handle in environment. They are very powerful, and the energy density containing it's very powerful that without a battery management system, it's not even safe to keep it in a steady state condition while you're not even putting the battery under a load or using it under a load, nor discharging or charging it. Just keeping it at idle status is a bit of dangerous for the lithium ions. So what all are the major parameters or the functionalities that a BMS takes place is that it can estimate the battery capacity or SOC. So as you can compare to your mobile battery pack, you would like to be updated what is the current status of your remaining SOC, whether it's 80%, 60%, so that you can plan all your further task with the phone, right? Similarly, this applies to the battery pack which for using a vehicle. So based on your remaining SOC, you could plan your ride or right. Then battery health estimation or SOH estimation. So how long your battery can sustain. For example, if you look at any data sheet, they would have given you that 2000 cycle, 5000 cycles for your battery pack, right? That's the complete life cycles of the battery pack. So the question is, what happens after those number of cycles run? So the performance or the quoted performance from the manufacturer would be not at 100% efficiency at that after those cycles. So your battery would take before 2000 cycles, your battery would take around 1 hour to charge. So and it would able to give you 2 hours of discharge. But after completion of 2000 cycles, that might change. So rather it would take a long time to charge, and it would give a very less amount of discharge. So certain decrease in its performance can be seen after the stated warranty period, or in other terms, I would say that life cycles of the battery pack. So, and using a BMS, you could predict the battery failure and even prevent it. That's the important. Before a battery completely fails, it can be prevented majorly by using a BMS. it acts like a safety device and protection logics. There are many protection logics placed in BMS. Whether you take it as overcharging when you have kept for a vehicle for charge overnight, or it can be regarding with the temperature control, or it can be regarding with the high discharge current. So any of these parameters, it can be protected in by using the BMS. Then one more major point is that charging and discharging monitoring. So a battery should be monitored while charging and discharging. That's what I was saying at the starting, right? Here you could see that these cells are not in a balanced state. Cell 1 has around 60% of SOC, then cell 2 has around 30%, and the third cell is around full charge. Right? It's not in a balanced way. So when you're charging this battery pack, this is not single cell. So inside a battery pack, there are n number of cells present. So if they are not in balanced state, and if a cell is completely charged within a 30 minutes, but still the current is being provided to charge the other neighboring cells, which still has to, which still is not as reached the 100% SOC, right? So when you do that, then there can be a lot of issues of overcharging a one cell and damaging it, right? So it's a very vital role of BMS to monitor either while discharging or charging. As I mentioned again about the cell monitoring and balancing, the diagnostics. A BMS has a capability of diagnostic too. When it finds a certain problem, for example, there's a the cell number 2 is in not in a balanced state. So it will make sure that along with an algorithm to send a required amount of current more towards the cell number 2 to get it balanced to its neighboring cell, right? And also it helps in communication. It can communicate with other device, with your vehicle level VCU, or when you're monitoring via any laptop to know the current status. One part, what is the life status of your battery pack? Also, how it performed. For example, you have taken your vehicle from Mysore to Bangalore. So how did the battery pack perform during the complete journey? What was the discharge current? What was the temperature of the battery pack? So all these parameters can be logged and also communicated. So here's just an example of a thermal runaway temperature of different chemistries, NMC, all are lithium batteries, but different chemistries, where one is of LFP, LMO, NMC, and LCO. So why I have put up this table is that you might have heard a lot of incidents nowadays in news that so and so X and YZ electric scooters catching fire while right in the mid of a day, while charging or while discharging, right? That's not the thing. That it's just with the temperature. Environmental temperature will just blast off the battery pack. That's not the thing. Each of the battery pack chemistries has its own thermal runaway temperature, where you could see it's pretty much higher when you compare it to the environmental temperature present here. So it's the BMS duty to play its all vital roles properly, so that any malfunctions doesn't take place and it's in a safe condition. Now we'll look at the BMS integration part first. How a BMS integrated. So this is a smart BMS here. This is what we call as a non-configurable BMS. So these BMS can be connected to your laptop or phone, and you can configure the parameters at any time, any number of times. But these BMS are once configured while manufacturing is all set. You won't be able to configure it. First, we look at the wiring or the schematics of the BMS on the hardware part. We won't be going in depth of which of the components are used here, these MOSFETs, resistors, what type of resistors and all. We would just look at the overview that how do we connect a BMS to a battery pack, which we are making or we are manufacturing it. So first thing, you can see that there's a term called B minus, which is nothing but battery negative of the battery pack. Then this is C minus. This is charge negative or discharge negative, right? Then you have a on-off switch. Some of the smart, this schematic is a representation of a smart BMS. Okay, the one which I was talking about, that which we can configure it. So it has an on-off switch. They have NTC sensors for temperature measurement at board level, also at the battery pack level. Then you have communication port. It can be via Bluetooth, it can be CAN, it can be RS485. So based on what type of communication is required for your application, that will be provided here. So we'll just look how we start the connections first. So first we start with the negative side. So here is your battery pack. You have negative terminal and you have at the end positive terminal. I'll just show you. This is the negative terminal, the blue thick wire, right? B minus is going to the negative terminal, and the positive terminal is directly taken from your battery pack. Similarly, you connect the first negative terminal, then in series, each of these white wires which you see now, they are connected for series connection. This is for the negative connection. This is for the charge or discharge output wire, common wire. So the positive is taken directly from battery pack. So in term to connect the complete series of the battery pack. So usually battery packs are in series, right? Series and parallel. It can be 13S and 14S, 17S for 68 volts. That's in terms of voltage. So a major configuration when you look at BMS is two things. One is discharge current, that is in amps, and one is series connection. So if you are making a battery pack of 13 series, you would obviously look at a 13S BMS with a discharge current of based on your cells which you have used. If it's I would say like your whole battery pack is of 30 Ah, you would be looking at 30 amps as a max discharge current. Or if they are 3C cells, you would be procuring a 90 amps BMS, right? So two major parameters are discharge current and the voltage or the series connection which you are opted for. So you connect with your negative part, the negative terminal. Then each series wires are connected in consecutive terms. Just show you in this part. So there is your E minus 1. This is your first wire. Black thick wire goes here. Then you have the first wire. This black thin wire can be seen. That is the first wire which is coming from the series connection port. So you have here, if this battery pack is around 13S, you will have 14 wires. Two will be, I mean, the one will be noted as a black wire for the first negative, and then another at the end will be a red wire for the positive. In between, it will be white wires to connect it in series. First, you get the first series. You continue with the second series, and then so on until you connect the last series, the 13 series or 14 series based on battery pack, to the series connection. Then at the end, which the positive terminal is taken as a direct positivity of your complete battery pack, right? So BMS takes place a role in majorly in the negative parts, and the complete positive terminal is taken from the battery pack. Right. I'll just explain you again. Go with the B minus, then each series wire goes to the series connection. You start with the 0, 1, 2, 3, 4 up to 13th, and finally you take out the positive wire. So, and the common port is taken care from the BMS itself. So either you can have single connection where you have one black wire for negative and one for positive red wire, or either you can keep two wires, one is for charging, one is for discharging. One more observation you can see here, these wires are very in size, right? Right? You could observe it. These are very thin and these are very thick. What is the reason behind this is because the wire should be able to allow the current to flow, right? The amount of current. So if you have 30 amps of current flowing it, so based on the 30 amps, what gauge has to be selected will be used here. So the thicker wires are used because they discharge high amount of current, right? 30 amps, 40 amps. These are high amount of current which are discharged. So thick wires are used. And one more, see there are holes here. That's for ports, I would say. They both belong to B minus only. Again, why do you have two ports here? It's just that if your current is let's take 60 amps, the wires which you use are being maximum it can take 30 amps. So you can split it. If rather than connecting a single very thick bold wire of 60 amps, you can take two wires of 30 amps and divide it. So the currents gets divided here into 30-30. So these are the MOSFETs which you can see, and these are the sensors which I was talking about. Usually these sensors are one or two depending on your application. These sensors will be placed inside these battery packs. You see the gaps, right, between the cell holders and the cells. So these temperature sensors will be placed inside it, and even the board has a separate temperature sensor where it will be providing you the data of the board's temperature. BMS boards, this board is there, no? That board's temperature will be showcased. So this was about the battery pack integration. I will make it more clear when you look at the video of how it is connected and all. Now we'll move further. Now, after you connect your battery pack, it's integrated with your BMS is integrated with your battery pack. Now you need to configure it, right? According to your battery pack data sheet, you need to configure it. So this is how software interface look like. Again, the software interface are given from the OEM itself. If you, it can be Orion, it can be JBD, which BMS you choose. They have their own software, but some BMS are made in certain way that it can be run via universal open softwares too, right? So there's an example of a BMS software. So where I have connected for a 48 volts battery pack. 48 is the nominal voltage. Currently, you can see the window has 4 parts. One is the pack information. Then you have a settings, calibration, and other functions. So when you look at the pack information, yeah. So you have number of series, voltage of each series, then the balance column, whether the balancing is required is on or off state. Then temperature, as I said, these had 2 temperatures. One was of board and one was of the battery pack. Then you have complete pack information where pack voltage, pack current, average voltage of the complete series, and max voltage, minimum voltage. What is the difference between each of this voltage, and full charge capacity? What is the remaining capacity? SOC percentage depiction. You have charge and discharge FET. FETs are nothing but MOSFET. Again, what is a MOSFET? It's nothing but a switch, a protection switch. I'll explain you further what it does. Then you have PCB version. So you might have a number of BMS. The software can detect a number of BMS. So in that, the one which you have attached, what is the version of it? 13S 40 amps, and their numbers are given here. And you have a warning window here on the right hand side. So if anything goes wrong, like cell over voltage protection takes place, then they'll have a warning symbol here. So you have a start and stop option here. You can also log this data. If you just click on the save data, complete from the moment you click on this, the data will be logged for 1 hertz. That's nothing but per second. So I was talking about this charge FET and discharge FETs, right? They're nothing but a MOSFET. So what does these MOSFETs do? For example, if overcharge take place, the charge MOSFET will turn off, so that it will keep remaining in off position until the overcharge or high overcurrent is being passed for charging. So this is the way how a BMS protects a battery pack from any other source while discharging or charging. If you over discharge it, it will just cut off the connection between the source and the load, right? So when you source is nothing but the battery pack here, load is motor or lights, anything it can be. So the BMS acts like a bridge in between, or like a gate in between. So if anything a malfunction takes place, it cuts off a connection between the source and the load. So by this way, your source is also protected, your load is also protected. So when we come to the next window here, we have settings window. So if you look at the settings window, there's a lot of options here. These are the basic parameters which we set of a cell, where you mention cell under voltage, over voltage, pack over voltage, under voltage, then charge over current, under current, what should be the temperature, charge over temperature, under temperature, discharge over current protection, and charge over current protection. You have an option for read, write, save, and open. So any parameters you change, right, you need to give write. So as soon as you write this, these parameters will be sent to the hardware part from software. You can save if you have multiple parameters to be tested. You can save them, you can open and read them. So once when there is an indication of read data success, then only your BMS is able to detect the one the hardware part, right? So now we'll concentrate on each of these basic parameters. So what are these basic protection parameters? I was talking about, like, see, here's an example. And a cell, when it's in a normal state, when it's discharged and charges, you can see the behavior. When it's overcharges, it produces high amount of heat. When it's undercharges, it will underperform, right? So in order to keep it in current normal state, what all protections or parameters we need to take care? So you have a cell under over voltage, under voltage, charge over temperature, under temperature, discharge over temperature and under temperature, and charge over current and discharge over current. So on the left hand side, you have the values where you set the max limit. For example, 4.2 volts is the maximum voltage of the cell which you have chosen. So these maximum voltages are filled on the left hand side, and there is something called as release value. So what are this release value and what is this delay seconds? Let us take that your maximum voltage is 4.2 volts. Now the BMS detects that the cell has been reached already, so 4.2 volts. So it cut off the charging. Now when it should release, or when it should allow the charger to again charge it, then that value is called the release value. So where you might give around 4 volts or 4.15 volts. As soon as this value is reached, again it will allow the charger to charge the battery pack. Again, this value will be checked after a delay seconds. So as soon as it cut off, you give a certain delay seconds in order to protect the battery, right? In order to protect, you give certain delay seconds. So let us take 5 seconds. So after 5th second is over, this it goes, checks whether the value is has been matching the release value. If yes, then it will activate the complete battery pack. If no, again it will deactivate and keep it in same state. Now the question is, on what basis do you set all this, right? Simply based on any other source of data, or based on your just of any other knowledge, you can't place these values. It has to be authentic way where you follow a data sheet provided from the manufacturer itself. So this is how an example looks of a cell datasheet. This datasheet is of BAK cell, where you can see that they would directly provide you what is the rated capacity, nominal capacity, at what C rate, what is the nominal voltage, what is the charge voltage. So charge voltage is nothing but the max voltage it can be charged, right? That's what I was talking about before. Then discharge cutoff voltage. What is the minimum voltage it can take place? What is the energy density? Max charge current. So this cell can be charged on maximum 1C or certain amps, not more than that. What are the temperature? When it's in storage, what should be the temperature? When it's in working condition, what should be the temperature? So all these things has to be taken care from what do I say? Like data sheet only. You should refer the manufacturer data sheet only for all these parameters. So now you looked at how do we change these parameters and all, right? Now we'll look at how does actually this balancing takes place in the motor controller, right? I was just saying that BMS has a function of cutoff and all. So how does it take place? You just look at this example. So in the figure A, you have 4 cells present here. They are of each different voltage, right? One is 3.5, 4.1, 3.4, and 3.7. Now you have allowed it to charge via charger. The BMS is allowing the current. As soon as you have set an amount as here 4.2 volts, it cuts off. See, it cut off the charger. So this is the source while it is charging the BMS, right? I mean battery pack. It's cut off the connection. Why? As you have already given, the 4.2 is the maximum. Now, after certain use, again the voltage will drop. So when the voltage drops to 4 volts, that has been set as a release value. This value which I was mentioning as a release value, right? As soon as it reaches the charger, the BMS automatically allows the charger to flow the current in. So by this way, it will make sure that the neighboring cells are getting balanced. So you can see on the fourth figure, 2 cells are already in 4.2 volts and their voltage has been increased. So on the end of the stage at figure F, you could see that all are charged up to 4.2 volts. So this is how a balancing take place via BMS, right? It cuts off and makes sure the amount of current is flown to other neighboring cell. So this process repeats until the complete battery pack is balanced. So similarly, when we look at the cutoff voltage, right? The value cutoff voltage is that at what minimum value after which the BMS should not allow the battery pack to discharge. So that part we have a load here, we have BMS here. Again, you could see that the cells are not in balanced state. So now we are keeping the BMS battery pack under a load. So it's discharging, right? As soon as it certain under cutoff voltage is reached, the connection between the load and the battery pack is cut off. So this is how the BMS protects the complete battery pack. So here is an example of when you're discharging how the software window looks like. So you can see the current is in minus 1.85 amps. That's nothing but negative. Negative stands for discharge and positive stands for charging, right? I also said we have an option of logging the data. So this is how the software allows to log you. So you get a time, date, what is the pack voltage, what was the current status, and complete cell series, series 1 to series 13th. Each values are recorded here per second, and the average voltage, minimum cell voltage, or say remaining capacity, full charge capacity. Also, it will record if balance status was on or any protection status was on or off. or even what was the status of the MOSFET. All these things can be recorded along with the temperature. So when you look at this was the basic protection level. So also these smart BMS has a second layer of protection where we call as high protection configuration. That's the thing when by miss there is a more inrush current than these values you have set. So in order to avoid any short circuit, there's another hardware level protection, also on software level protection. Then you have other functions like charge function, balance function, charge balance, and a static balance. So what this charge balance means that when you click on that, the BMS will only balance while charging. So if you click on static balance, the BMS will balance the cell even when it's not charging, nor either it's discharging. So in a steady state condition also, it makes sure that all the cells are in balanced form. Then you can select how many number of thermal sensors are used, or the NTC sensors are used. What should be the start voltage and the balance precision for balance configuration? What will be the capacity configuration based on the percentage? So what this does is, based on this data, your BMS will be smart enough to predict the current status of health of your battery. So let us say you have purchased your battery pack now. So after 2 years, your battery won't be performing the same, right? But your BMS should be able to know that what is the ability of your battery at that moment. If it is not able to understand it and show the results to us, we won't be able to plan our ride, right? For example, you have an electric car. At present, at starting, it would be giving you 200 kilometers of range. So based on the range, you would decide where to go, right? After 2 years, if the BMS is not able to give the actual health status, it would still be depicting you the 200 kilometers. But in reality, you won't be getting that much, right? It will be lesser due to the usage of the battery pack, due to the discharge and charge and all, right? So whenever the BMS is able to measure the state of health, then it could give the user or the consumer more accurate data. So now I would like you to present a video on what all I explained, all these functionalities. How does it takes place in reality when we connect it to the battery pack? Okay. This video has been uploaded in YouTube. I'll just is my audio audible? Hello. .7 volts. So as I was showing you all how the BMS integrated and what is the basic configuration. For example, this battery pack here, you can see it is written 30S and 30 amps. That's nothing but what is a series combination and discharge current. And as I was mentioning, you have series connection wires. One is a negative at the one end and other end as the positive, another for the series connection. So it's around 48 volts, 10 Ah capacity. When you talk about the connection with the BMS with the battery module, you can see there is something called as B negative. There is nothing but battery negative. This directly goes into the negative terminal of the battery. Then we have C minus, which is nothing but charge negative, which will also be a discharge negative. Then we have UART and RS485 for communication purpose. Here you can see the communication module is here, which will convert RS485 to directly to the USB, which you can connect to your laptop. Then the main wiring comes here, which connects all the series of the battery module. It starts from negative wire, which is known as BC0, which will directly, the black wire, which will directly connect to the negative terminal. So total we have 14 wires, out of which 12 are white, one is negative, one is positive, which is in red color. So first you connect to the negative terminal, then in continuation you connect all the white wires, which you can see here, it has been already connected, and here. Then at last you connect the red wire to the positive terminal. So this is how the wiring connection is. Here you can see the thermal, that's another thermistor which will monitor your temperature. This will be actually placed inside the battery module. Some BMS has overall board temperature sensor also, and external more than 2 or 3 temperature sensors. So this is the terminal which is used for discharge, also for charging. In some BMS we can connect extra wire for a charge separate and discharge separate. And this is the wire for the communication. This is the communication block. From here you get a USB connection. You can see in the battery module again we have one for charging, which is connected at the ahead front for charging port, and another for discharging, which is directly connected to the load, that is motor. Then we have two wires, B minus, which will go directly into the negative terminal of the battery pack. Then we have taken positive terminal, positive wire directly from the positive terminal of the battery module. These are the 14 wires, in which 13 wires are directly connected for the 13S connection, series connection in the battery module. Another one wire is for the positive terminal. How to connect it? Just connect the USB. So now you'll be looking at how the software is connected to the battery pack. Connection here through the communication block. Then just go to the COM. Click on the COM port. So as soon as you open the software, this window pops up, and then you just click on the COM port. Automatically it will select the COM port which has been connected. Press OK. Then you give start. Go to the settings. You press read emperor. It reads whatever data or parameters which has been set for the particular BMS module. You can see reading data is successful. If you go back to the pack information window, it will give you the current status of the whole battery pack. The module is 13S 40 amps, which you saw already. So when you talk about the pack information, basically you have number of series connection, so which is 13. So you can see 13 connections here. Then when you can see directly the voltage in series. So there are four cells in the parallel, or 10 cells in the parallel, you can see. So all the voltage of the in that particular line in series 1, the voltage is seen. You can see for all the different 13s. Then we have something called balance function. If by chance any cell voltage is below the parameter which we have set, then you can see on and off function of the balance. Then we have temperature sensor. One temperature sensor is inside the battery module, another temperature sensor is of the BMS module. Then we have overall information about the pack volume, which is 49.8 right now, 49.8 volts. Then we have current. Right now it's 0 because neither it's discharging nor charging. Then we have average cell voltage. Then you can see maximum cell voltage, minimum cell voltage, different between the cell voltages. Then we have cycle count. Cycle count is nothing but our life cycles, or a life cycle for a cell is complete discharge and charge. That's called a one life cycle. So you can also calculate the state of health using smart BMS. Then we have full charge. What is the full charge? As I said, it's a 29 Ah battery pack, so that's the full capacity charge. Then we have remaining capacity. We also have the remaining state of charge. Then we have two MOSFET here. One is for charge, one is for discharge. On the right hand side corner, you can see these are all the window for the any warning symbol. Maybe cell over voltage protection, charge over voltage, charge protection, discharge protection. If anything malfunction is detected in a BMS, you can see a warning window here. Now let us go to settings. If you look at the settings, here you can see. So this is what I was explaining in the before time, right? So how do you connect? So now we'll directly look at how does discharge cutoff or overcharge cutoff happens. So for that, you could see that just for the demonstration purpose, I have kept the value as 1 amps for charge over current and 1 amps for discharge over current. So as soon as if I provide a charger which is above 1 amp, then it should cut off. And if I discharge above 1 amp also, it should cut off, right? So we'll look at that part. And at what temperature we can charge it. In the current window, there is 4 amps going in. So now I've set the parameters for 1 amps and I've allowed the charger to charge the battery pack. So it's a 4 amps charger which I've used. So it's giving 4 amps continuously. So which is above our protection or the limit which you have set, right? So as soon as the battery pack BMS detects it, so you'll see what will happen. This is above the parameters we have set. Yeah. You could see that charge MOSFET from green went off to gray. So green states that it's an on and gray position states that it's off. So it detected that charger is allowing or passing over current to the battery pack, which is not safe for the battery pack. So as soon as it detects, it cuts off the supply. You see, suddenly there is a charge MOSFET getting off, which is in gray color. So you could see the charge MOSFET from green it went to gray, which was in on state, suddenly it went for off state. That was due to maximum amount of current was passing according to the parameter set. So we had set 1 amps and it took 4 amps from the charger. So charger was providing 4 amps, so which was above the limit. So you can see this is the way how it protects while charging. I'll show you again. So we are getting 4 amps. You can see here on this window charge over current protection. So as I said, the starting window is for warning window. So you'll see a red warning symbol on the particular parameter which went wrong or which was in malfunction. For example, charge MOSFET. So the red warning is shown for charge over current protection. So basically for all these protection parameters, you'll see the warning window if anything goes wrong at that moment. Yeah, you can see this red blinking light, right? Which means that it will deactivate the whole system. Okay. And it keeps on repeating until unless the charger is allowing the current only which is in the protection limit, right? Which is in the safety limit. Once it allows once it passes that amount of current, then only the BMS will allow it to enter the battery pack. So this was about the charging. Now let us look at the discharging. You can see our test vehicle speedometer, it's in 0. The vehicle is in on. I'll start giving acceleration. You can look at the window now. Current is in 0. As soon as I give acceleration, it is going up to minus 1.7. And so it goes up to minus 1.73 with no load condition. So at minus 1.73, minus 1.7 amps is drawn from the battery pack. And at that moment, again, that is above the safety parameter which we have sent of 1 amps. You could see that it will cut off discharge FET this time. And you'll have a warning symbol at discharge over current protection. And it's getting deactivated. Why is it negative symbol? It is discharging current. You can see that discharge MOSFET will get off. You can see from from green it's going for gray, and you can see a warning symbol here. Yeah, you can see So if you have any other doubts on this video part, you can always go back to our channel and check our BMS demonstration video where you'll get more. Your doubts can be clarified there, right? So now we were looking about what are the parameters or functionalities a BMS can do, how do we integrate it, all this part. Now another major part of BMS is cell balancing. So what is cell balancing? Why do we need it? And what type of cell balancing can take place in via BMS, right? On the right hand side, you could see that there's a GIF which is presenting that when a battery pack is being discharged, if it is not in a balanced state, all the cells are not in balance, you could see that the cell number 1 is able to only discharge certain amount, whereas if you compare to the last cell, it's getting emptied faster. So a healthy cell or a balanced cell will perform something like when it charges, it goes from 15, 20 or in a ordered wise and gets completely charged. So here is a picture depicting the balanced and unbalanced. So what happens if you have same voltage, it's a balanced state. After some usage or some years of usage or some, right, it goes into an imbalanced state where a certain number of cells will be in higher voltage compared to the other. So that moment, your remaining SOC will be shown as 40% or 60%. But in reality, you won't be getting that amount of capacity to usage. So, but when you balance it, the remaining SOC showcased will be shown in reality way. So this is the actual remaining SOC which you can be used. But if they are not balanced, this is the amount of SOC which you will be seeing. Again, to emphasize more on what is the importance of the balancing, right? So here we have a graph where it shows that cell SOC versus battery SOC. So this was cell SOC versus battery SOC, right? So cell SOC, if you see it's in a balanced state or an ideal condition, it's in a proportionate way. But if it is if it is in an unbalanced way, then you could see that the battery remaining SOC might be different, but in the actual cell SOC will be different. That's why it's very important to have the cells in a balanced state. So again, I'll just give an example. What happens when you balance, or what happens when you don't balance the cell? We have two cells here. One is of 90H, one is of 120H. The battery capacity in gray is wasted and white is usable here. So it's from 0 to 100% here. It's only 0 to 50% here. So balancing is off at this state. So what happens if you start balancing it? So there is a difference between the capacity, right? As soon as you start balancing it from 60H, the battery overall battery pack capacity increases to 70. Then again it increases to 80, and again it increases to 90. On the process of balancing, you could see that this white gap is being increased and the gray gap is being decreased. So by balancing, you will be able to use more amount of battery capacity. If it is an unbalanced way, you would be just wasting certain amount of capacity of the battery, right? Now, when we talk about balancing, what are the types of balancing which you see in battery BMS? So I'll just explain once in a layman term. Let us take that you have 4 glasses of juice. They are not in equal quantity. Some has 150 ml of juice available, another has 180, and it's in an unbalanced state. So if I give these 4 glasses to you and ask you to balance, in what way could you balance? Right? Two things comes in your mind. Either you can pour out the juices to the outside environment and try to match all the glasses. So there your balancing is being easy. You're just pouring it out to just match it. But also you're wasting the juice, right? Another method can be either you take the large amount of glass which contains a large amount of juice, and with precision you make sure that you distribute to all the neighboring glasses to get it in a balanced state. So same thing applies in BMS while balancing. So when you just pour out the amount of current is called as passive balancing. But when you distribute the current or the energy from one cell to a neighboring cell to balance is called active balancing. So what happens in active balancing? You have a large amount of energy in particular cell. It goes through algorithms and calculates what is the amount of energy which has to be transferred to neighboring cells to match up, and only that amount of energy will be passed from each from that cell to all each cell and get it balanced. Same while discharging, if a particular cell has very less voltage and other cells has comparatively high, so all these higher capacities will pass on the energy to the lower one to balance it. This is how active balancing happens. So here the advantage is you're not wasting any form of energy, but it's very complicated that only certain right amount of energy only has to be provided to match it up. So that's a lot of algorithms taking place there. And if by chance you provide more amount of energy, then the cell can start acting like a internal resistance, and it might uh, end up in being uh, uh, in a hazardous situation, right? So what happens in passive balancing? You have shunt resistors, which you are able to see in the schematics. So as I said, this is a first method which I was explaining by giving an example of juice, right? You pour the juice out. So how do you do in BMS is you use shunt resistor, you allow the current to pass through it and it dissipates in the form of heat. For example, cell 1 has high number of higher capacity when you compare to all other higher remaining SOC when you compare it to all other cells. So in order to match up with all the three, what it will do, it will pass current via shunt resistor, and it will flow out in the form of dissipated heat. Then by this process, it gets the whole overall battery pack into balanced state. That's it. Thank you. So
Thank you, Shandy, for the session.
yeah, thank you.
I'll just stop sharing the screen. Yeah, good evening, everyone, once again, and thank you for attending the session. I have a few courses which I can suggest you. We provide master courses for the students who are passed out, and micro specializations to upskill your skills and get ahead. And we also provide educational internships. Yeah, the courses we provide for automobile, mechanical, aerospace, robotics, and mechatronics students, and electrical, electronics, and instrumentation students, and CS and information science students. You can explore the courses here. I'll just leave a link in the comment box. You can explore the courses, and these are all the internships. You can complete it during your vacations, which are helpful for your academics as well. Let me just show you how you can generate your certificate. I'll just share you the certificate link. Just hold on. I have just shared you in the comment the link to generate your certificates. All you have to do is click on the link and you'll land up in this page. I have to go to, if you have not signed in or if you have not logged in, you just have to sign in or log in to your website, to our website, and then go to my account, and then please check for your name. Please check for your email IDs, names, and other details which you have to fill up, and hit on save changes, and then you can just come back and click on the enroll now button. It will be enroll now there. You just have to go through all these steps. These are the same thing which I have just shown you, how to generate your certificate and all, and what are the corrections you have to do in the account or profile section. And you just have to click on continue, and you can read all the information which we have provided and how we can share your certificates in the LinkedIn. And click on continue, and here you can get your certificate. Just a second. You'll get the certificate here, and you can just copy and save it somewhere, the link, and you can download it as a PDF, and you can share it on the social media platform or professional platforms like LinkedIn. Do tag us if you upload it on those platforms. Thank you. It's not coming. The certificate will be similar to the sample certificate which you have provided. Yeah. Thank you everyone for joining in, and thank you Srinidhi for the wonderful session. And
Thank you.
And thank you for all the college fraternity who has helped us to do this webinar. Thank you.